Hi students! After completing preparation of haloalkanes from alkane, we move to the second method to prepare halogen derivatives of alkanes, and that is from alkenes. So look at the board. In order to prepare a haloalkane from alkene, we make use of hydrohalogenation, where we add a hydrogen and a halogen across the double bond. We add hydrogen and a halogen, that means we are adding halogen acids. One important thing I'll mention here, the order of reactivity of halogen acids is Hi greater than HBr greater than HCl. Before we add the halogen acid to an alkene, we should understand the categories of alkene. There are two subdivisions, the symmetrical alkene and the unsymmetrical alkene. Now the question which comes to the mind is how to find a symmetrical and an unsymmetrical alkene. So look across the double bond. When you look across the double bond, you find same number of carbon and hydrogen across the double bond, then it is a symmetrical alkene. Look across the double bond, we see number of carbon and hydrogen are same, so it is a symmetrical alkene. Look across the double bond, the number of carbon and hydrogen are not same, it is an unsymmetrical alkene. So now we proceed further and we look at the addition of halogen acid across a symmetrical alkene. This is a symmetrical alkene, children. This was just a skeleton. This is a complete structure. Ethene reacts with HCl to give ethyl chloride, where hydrogen gets added to one of the carbon of the double bond and chlorine goes to the other carbon of the double bond. Reaction takes place only across the double bond. Obviously, that's the functional group. Whenever a pi bond reacts, one of the pi bond breaks to form the two sigma bonds. So the unsaturated molecule became saturated. Similarly, butene reacts with HBr to give 2-bromobutane. And we can get only one product because the alkene is symmetrical. Now when we move to understanding the addition across an unsymmetrical alkene, then we find when an unsymmetrical alkene is treated with a halogen acid, then the negative part of the reagent bromide gets attached to carbon having less number of hydrogen atoms. When an unsymmetrical alkene is treated with a halogen acid, say HBr here, then the negative part of the reagent gets attached to carbon having less number of hydrogen atoms to give 2-bromopropane. Where bromine got attached to carbon having less number of hydrogen atoms across the double bond. This is called Mechanicus Rule. Similarly, when I take unsymmetrical alkene butene and I treat it with HCl, then you see negative part of the reagent chloride gets attached to carbon having less number of hydrogen atoms across the double bond. So we get 2-chlorobutane. Surprisingly, if I take same propane, same propene, and I treat it with same HBr, here in absence of peroxide, here in presence of peroxide, then you see a twist. That is, negative part of the reagent only in case of HBr, and in presence of peroxide. The negative part of the reagent bromide gets attached to carbon having more number of hydrogen atoms across the double bond and we get 1-bromopropane. This is in accordance with Mechanicus Rule. Mechanicus Rule, which is also called peroxide effect. which is also called Kerashmayer effect. Now we apply Markovnikov's and anti-Markovnikov's rule on one more example. Look at this structure. This is 1-methyl cyclohexene. This is 1-methyl cyclohexene. I am treating it with HBr over here. I am treating it with HBr over here. Absence of peroxide, presence of peroxide. In the absence of peroxide, children, Markovnikov's rule is followed only in case of HBr. But in case of HCl and HI, whether you use peroxide or you don't use peroxide, it is Markovnikov's rule only. If I use HBr with peroxide, this is anti-Markovnikov's rule. Now what was Markovnikov's rule? That the negative part of the reagent will get attached to carbon having less number of hydrogen. So negative part of the reagent, that is this, gets attached to carbon having less number of hydrogen, so attack. And I'll be getting the product like this, where bromine comes on the carbon having less number of hydrogen. So I got 1 bromo, 1-methyl cyclohexane. But same reaction, if I put peroxide, then the negative part of the reagent will go to carbon having more number of hydrogen, and the carbon having more number of hydrogen across the double bond is the adjacent carbon, not this carbon but the adjacent. So the product is 1 bromo, 2-methyl cyclohexane. With this we complete the discussion of preparation of haloalkanes from alkene by hydrohalogenation. So bye-bye, take care, stay blessed, love and blessing to all the students over there.